Hi everybody. You need your guided notes for numbers again, and you should be on page 2 right below where it says scientific notation. We've already filled that information in. We should be focusing on the section that's called accuracy and precision. So we wanted to talk briefly about this concept so that we can apply it a little bit throughout the school year. So the big deal is that we really need a measurement to be useful. And in order for a measurement to be useful, it needs to have certain things. It needs to be a reliable piece of data, which data can be measurements. And with the reality that there's going to be some level of uncertainty in that reliability. So there are several things that we're going to be using to help us demonstrate the whole idea of reliability with measurement, uncertainty in measurement, as well as accuracy and precision in measurement. So we're going to talk about significant figures together as a whole group, and then we'll also cover the idea of percent error. And then we're going to look briefly here now at accuracy and precision. And what I mean by reliable and having some level of uncertainty with measurements is that, remember, there's human error that's involved with measurements. And then, of course, the type of equipment that we're using can also display some level of inaccuracies. So your graduated cylinders that you explored earlier in the 9 weeks, as well as cross-comparing against a beaker, most of you chose, if not all chose, that the graduated cylinder would give us more precise measurement capability, and that the beaker was less precise, that there wasn't as many lines on the beaker so that I could measure out a more specific quantity of fluid. And also realizing that the equipment in and of itself might vary in how well it's made. So it might say it's a 50 milliliter graduated cylinder, but what if that marking really wasn't manufactured to mean exactly 50? So that's what I'm discussing when I mean that we want our measurements to be reliable. So we want to use quality material, and we want to use care when we're deciding what that measurement size is, but also realizing that we're not perfect when we've decided that we think something's 50 milliliters, and neither is the equipment. All right. So, excuse me, just to cover that thought again. So, how well you chose to measure your materials is a direct indication of how accurate and precise you might be able to measure. Who does the measuring each time? Sally might see 50 milliliters a little bit different than John sees 50 milliliters. The type of instruments that we're using, which I just discussed. And these are a few examples of things that we'll run into this year. Now, we'll use the same balances throughout the year, but it doesn't mean that each balance I have out equally measures. So you want to be consistent with using the same balance each time throughout a class period. As well, you also want to use the same graduated cylinder throughout the experiment process. All right, so what is accuracy? Accuracy is simply the closeness of your measurements to the accepted value in society. Society being a general term. Precision is the closeness of your measurements to each of the other measurements that you are making, but not necessarily close to what the general accepted value is. So accuracy is how close are you getting to what has been stated to be the accepted value, and precision is how close are each of the measurements that you make consecutively, but not necessarily having anything to do with that accepted value. So what we can do, this is a great way to really look at the difference between accuracy and precision. So we can take a dartboard. Now I hope that everybody would agree that the little black dot in the center is the bullseye, correct? And isn't the bullseye what has been generally accepted by society to be the center point on that dartboard? And that's what everybody's goal is to try to reach, is get that dart into that bullseye area. You earn more points whenever you get your dart in that area, and you're considered to be a much more skilled dart thrower whenever you can hit bullseye. Now, if we look at this illustration here, we'll see that all 3 dart throws are pretty much they're on or near that bullseye. So this person threw with high accuracy because each successive throw led them either close to or right outside of the bullseye, and they're also very precise because each of their measurements was close to one another. Now our second one here, you can see that they're not anywhere near the bullseye. But aren't they consistent with their dart throwing? So this individual is low accuracy because they're not reaching what the standard is, that bullseye. But each of their successive throws, they're hitting the same region on that dartboard. So they've got consistency, which means they have high precision. And this one's a little bit more abstract, but let's look at the thought on this one. Now, would you say that all 3 of their dart throws were close to bullseye, but they're not really close to one another? That's right. So this person is throwing with high accuracy because all 3 of their dart throws are close to the bullseye, but none of their dart throws are really close to each other. So this person has high accuracy because they're throwing close to what has been decided to be the high standard, but they're not really consistent with each of their throws in the same area, so their precision is low. And last, this would be me. No, the accuracy is terrible, and so is the precision, right? So if we look at this here, this person is not very consistent at all. They're nowhere near bullseye, so they're not meeting that accepted value, right? So they don't have very good accuracy, so that's low. Their precision is also low because each time this person threw their dart, it's nowhere near their other ones. So they have low accuracy, low precision. Thank you.